In geometry, there were special triangles that you had to memorize, the 30, 60, 90, and the 45, 45, 90 triangle. Now, we're actually going to be using the angles within those triangles in Algebra 2 a lot. So there are angles within those triangles that we really need to memorize. We need to memorize sine, cosine, and tan of 30 degrees, 45 degrees, and 60 degrees. Now, there's a little trick that you can use to help you memorize them. All right, so this is how it works. Within the chart, we're first going to start with the row representing sine. We can label this 1, 2, 3. And then cosine works backwards. We're going to label this 3, 2, 1. And we're going to take each of these numbers and we're just going to put them right over 2. Now what you're going to do is you're going to take the numerator of each of these fractions and you're going to put a radical over it. So we're going to need, well, technically the square root of 1 is just 1. So you don't have to put the radicals over the 1s, but let's put the radicals over everything else. Okay, so now once we get to tan, you just have to remember that tan of 45 always gets a big fat 1 right there. Okay, and then tan of 30 and tan of 60, they both get radical 3s. But because the 30 starts with a 3, it has that extra 3, we're going to put that extra 3 underneath the radical 3. So these are the values of our special angles. These you're going to have memorized. As long as you really, memorize the tricks of the chart, it's really easy to do. All right, so now let's talk about what a reference angle is. A reference angle is the positive acute angle made by the terminal side and the x-axis. All right, so what that means is, let's say we have a first quadrant angle here. Okay, so here's our angle. The reference angle is really just the angle itself. It's the positive acute angle made by the terminal side, which is this right here, and the x-axis. So whatever your first quadrant angle is equal to is going to be your reference angle. All right, so now let's say we're in the second quadrant over here. Well, if we have a second quadrant angle, okay, so where I'm putting this red arc right here, the reference angle is actually going to be outside of our angle right here. Because again, the definition of a reference angle is the positive acute angle formed by the terminal side and the x-axis. So the reference angle is this right here. It's outside of your second quadrant angle. All right, if we're in the third quadrant, so let's say we have a third quadrant angle. So it's going to start over here and it's going to go all the way past the first quadrant, past the second quadrant, and into the third quadrant. Well, the reference angle here would just be this little component, because here's your terminal side and here's your x-axis. So this is the angle in between them. And then if we take a look at the fourth quadrant, so the fourth quadrant angle would go, past the first, past the second, past the third, and into the fourth quadrant. Well, your reference angle is going to be outside of the fourth quadrant angle, because if this is your terminal side and this is the x-axis, here's the angle that's formed in between them. Okay, so let's now suppose that we know the angle measure of our first quadrant angle or our second quadrant angle, or no matter which quadrant you're in. There's rules that we're going to apply that will help us find our reference angle if we know the actual big angle itself. So let's start with quadrant 1. Quadrant 1 is pretty straight to the point. If we know that the first quadrant angle is equal to 60, well, since the reference angle is the same thing as the first quadrant angle, it means our reference angle would have to be equal to 60. So the reference angle is always equal to theta. It's always equal to whatever our first quadrant angle is. So in this case, it would just be 60 degrees. All right, now in the second quadrant, if we know that this angle right here, if we have a second quadrant angle that's 120 degrees, if we wanted to find our reference angle, well, if you notice, the reference angle and the second quadrant angle itself form a straight line, which is 180 degrees. So if we wanted to find the measure of this reference angle, we could just take that entire half circle, which is 180 degrees, and subtract off the second quadrant angle, the 120. So if we wanted to find x, our reference angle, we could just take 180 and subtract off theta. Or in this specific example, we could take 180 and subtract off 120, which again is going to give us a reference angle of 60 degrees. All right, so now let's look in the third quadrant. Let's say we have a third quadrant angle of 240 degrees. Well, if we want to find our reference angle, this angle right here between the terminal side and the x-axis, well, we know from here to here is 180 degrees. So what we can do is we can take this big angle and subtract off the 180 degrees, and that'll leave us with x, which is our reference angle. So basically, x is equal to the big angle minus 180. So x equals the big angle, which I'm going to call theta, minus 180. So in this case, since theta is 240 degrees, it would just be 240 minus 180, which is 60 degrees. All right, and then that finally leads us to our fourth quadrant angle. Well, we could see here that if we're given a fourth quadrant angle, right, the fourth quadrant angle plus the reference angle make a full circle. And a full circle is 360 degrees. So if we want to figure out what this reference angle is, let's just take our full circle. So let's take 360 degrees and subtract off theta, subtract off the given angle. So basically, x, your reference angle, is equal to 360 minus theta. So in this case, it's just 360 minus 300, which again is 60. So each of these pictures display a reference angle of 60 degrees. And again, to sum up our rules, in the first quadrant, the reference angle is just equal to theta. It's just equal to whatever the first quadrant angle is. In the second quadrant, the rule is 180 minus theta. It's 180 minus the second quadrant angle. In the third quadrant, it's theta minus 180. It's the third quadrant angle minus 180. And in the fourth quadrant, it's 360 minus theta. It's 360 minus the fourth quadrant angle. All right, so I have our rules at the top of the page here, and what we're going to do is we're going to use these rules and apply them to, certain types of problems that you may see. Now, I just want to remind you, it's a good idea to always write out this chart at the top of your page when you're dealing with, problems involving reference angles. And the other thing I would include in that is all students take calculus, okay, because we're going to need that, you'll see as we go through some of the problems. All right, so let's take a look at number one. It says to express as the function of a positive acute angle. So when they say function, this right here is a function. Sine is a function, cosine is a function, tan is a function. But this right here, although it's a positive angle, it's not an acute angle. Keep in mind, acute is an angle that's less than 90. So if we're looking for an acute angle, the angle needs to be between 0 and 90 degrees. So basically what we're looking for is the reference angle that's associated with each angle given in these examples. All right, so if we want to find sine of 150 degrees, well, 150 degrees, that would be in our second quadrant. So let's apply our second quadrant rule. Our second quadrant rule says 180 minus theta. Okay, so in this case, since theta, our second quadrant angle, is equal to 150 degrees, we could just do 180 minus 150, which is 30 degrees. So sine of 150, we can come back up here and we could say, well, that's equivalent to sine of its reference angle, sine of 30 degrees. Now, one other thing you have to think about, and this is why I wrote on top, all students take calculus. Since we're in the second quadrant, we want to say to ourselves, well, is sine positive or negative in the second quadrant? Sine is positive in the second quadrant, so we're going to leave this as a positive sine of 30. So this would be our answer. All right, if we take a look at number 2. Now, number 2 gives us cosine of 225. 225 is in our third quadrant. So we're going to apply our third quadrant rule, theta minus 180. So this time, theta is 225. Theta is our third quadrant angle that's given. And if we subtract these, we wind up with 45 degrees. So we can come on back up here and write this as cosine of 45. Now we have to determine whether this is going to be positive cosine or negative cosine. So let's look again back up here. Since we're in the third quadrant, the only thing positive in the third quadrant is tan. And since we're working with cosine, cosine of 225 is actually going to be equal to negative cosine of 45. Because again, cosine is negative in quadrant 3. So cosine of 225 is equal to negative cosine of 45. Okay, so here we're given the same exact examples, just different directions. this time, instead of writing it as a function of a positive acute angle, they want us to find the exact value. So it's just one extra step. All right, we're going to start these the same exact way. So again, sine of 150. 150 is in the second quadrant. So we're going to apply our second quadrant rule, which says 180 minus theta. So since theta is 150, when we subtract these, we wind up with 30 degrees. So, okay, since we're in the second quadrant and sine is positive, I'm going to leave it as a positive sine of my reference angle, which is 30. So we get positive sine of 30. Now, since it says to find the exact value, we're going to have to think back to that chart that we made earlier on. So I'm just going to write the chart over here, sine, cosine, and tan. We'll make our little box. And we know we have 30, 45, and 60. And again, it goes 1, 2, 3, 3, 2, 1. Let's put all of these over 2. And let's put radicals in our numerators. But again, the square root of 1 is equal to 1. So you don't need the radical over the 1. Okay, then tan of 45 is always equal to 1. And the tan of 30 and 60 both get radical 3's on the top. But since we have that extra 3 there for the 30, we need to put an extra 3 on the bottom. Okay, so now to go back to our problem in number 1. It says to find sine of 30. Well, let's look on our chart. Sine of 30 is equal to 1/2. So what we'd say here is this is equal to 1/2. Okay, we just take it a step further. All right, let's try cosine of 225. So again, 225 is in the third quadrant. So our rule for that is theta minus 180. So since theta is 225, 225 minus 180 is 45 degrees. So let's come back up here and write cosine of 225 as an equivalent form with a positive acute angle. Since cosine is negative in the third quadrant, we're going to have to write this as negative cosine of our reference angle right here, which is 45. Okay, so now this is equal to, let me bring down the negative sign, and since cosine of 45 is equal to radical 2 over 2, let's bring down a radical 2 over 2. So our answer is negative radical 2 over 2.